Okay, good morning, students. Present topic is interpolation with unequal intervals. In this, the first method is Newton's divided difference formula method. Let the given data be let the given data with unequal intervals of x be x0, x1, x2, x3, and so on, xn, corresponding y values y0, y1, y2, y3, and so on. Earlier, we saw with x values equally spaced, now unequally spaced. Then the Newton's divided difference interpolation formula is as follows. Y of x is equal to f of x is equal to y naught plus x minus x naught into y of x naught comma x1 plus x minus x naught into x minus x1 into y of x naught comma x1 comma x2 plus x minus x naught into x minus x1 into x minus x2 into y of x naught comma x1 comma x2 comma x3 plus and so on. Here, this highlighted one, unknown values, these are called Newton's divided differences. Newton's divided differences. These highlighted ones we are going to calculate using the table. That table is called divided differences table. These are called divided differences, which are defined as follows. First order formula, second order differences, the corresponding formula, and the third order differences corresponding formula. Instead of these formula, in the table you can see easily. We can represent the above divided differences easily in a divided differences table. This Newton's divided differences interpolation formula is also called as Newton's general interpolation formula. So this formula you can use not only for unequally spaced, equal spaced also you can use. This is called, that is particularly for equally spaced Newton's forward and backward interpolation formula. This is general interpolation formula. You can use for anyone, any type. Okay, for problems using Newton's divided difference formula, estimate f of 9 from the following data. X values are given, corresponding function values are given. Now, if you observe 5, 7, 11, 13, 17, these are not equally spaced. Okay, from the given data, we have x0, x1, x2, x3, x4, and y0, y1, y2, y3, y4. We know that the Newton's divided difference formula is formula you noted, take it as equation 1. Now the above divided differences can be obtained from the following table. First, x values x0, x1, x2, x3, x4, y values y0, y1, y2, y3, y4. And first order divided differences are y of x0 comma x1. How it will come means numerator is these two differences and the denominator is these two differences. Divided differences. Y1 minus y0 divided by x1 minus x0. Similarly, next this one. Then second order differences. Numerator values are first order differences. Denominator values are extreme end values, x0 and x2. Here x1 and x3. Here x2 and x4. Numerators are previous differences only. Then third order. See, why you are not going for fourth order means these are the same values. Same values, difference is 0. Numerator is 0 means everything is 0. So 0 into anything is 0. So no need to consider. Now list out the upper diagonal values only here also. Then substitute in the formula. Substitute in the formula, you'll get f of 9 as 810. Next. Construct the Newton's divided difference interpolation polynomial from the following data. So instead of asking particular value, it is asked to construct the polynomial which satisfies these given values. You list out x values and y values, Newton's divided difference formula, and the table for divided differences, x values and y values, first order divided differences, second order divided differences, third order divided differences, fourth order. Take the upper diagonal values, which is required to substitute in the above formula, substitute in the formula equation 1 and simplify. You will get the polynomial as 3x power 4 minus 5x cube plus 6x square minus 14x plus 5. Next, evaluate f of 8, f of 9, and f of 15 from the following data. Same. List out x values and y values, list out Newton's interpolation formula, divided difference interpolation formula, and divided differences table, x values, f of x, y values, first order differences, second order differences, third order differences, same, not required the fourth order differences. Even if you take also, zero will come. Generally not required. Up to here only it is enough. Now substitute the values in the interpolation formula. Okay. We are finding the polynomial here. Why? Because means it is asked 3 to 4 values. So better to take the polynomial and substitute the required points. F of 8, f of 9, and f of 15. Okay. Next, fit the cubic polynomial which passes through the points 2, 4, 4, 56, 9, 711, and 10, 980 by using the Newton's general interpolation formula. List out x values and y values. List out the Newton's general interpolation formula or divided difference interpolation formula. Construct the divided differences table, x values, y values, first order differences, second order differences, and third order differences. Substitute in the formula. You will get the polynomial. Next, here instead of giving points, they mention terms of suffix. Instead of y, they use it as u. U naught means at 0 it is given, 1 is given, 4 at 8, and at 10 is given. List out those values as x naught, u naught. So u I am taking it as y. Same procedure by the Newton's divided difference formula. We have to take divided differences table, x values, u equal to y values, first order differences, second order differences, third order, both are same. So fourth order not required. With the above values, equation 1 gives y equal to y of x is equal to u of x, polynomial came. Then if you want any particular value, you can substitute. These are the problems for practice. Okay, in the same manner, you can practice these problems. Okay.